Hi everyone, welcome to our Introduction to Deep Learning final project presentation. Today we will be discussing our project, which is extending multilingual XLM-RoBERTa to the Voynich Manuscript. So the Voynich Manuscript is a handwritten document written in the 15th century. Both the author and language of the document are unknown. However, the manuscript contains 6 known sections, which are Herbal, Astronomical, Biological, Cosmological, Pharmaceutical, and recipes. No successful research has applied deep learning to the manuscript, and we will be using some data that has been pre-processed by our mentor, Jacob Lee.
These are the goals of our project. Firstly, given a span of text, we predict which of the sections it belongs to using transform-based language model. Next, given 2 spans of text, we predict whether they come from the same section based on text similarity. And finally, we use SHAP values to determine the words that contribute most to each section of the manuscript and identify the words that have the greatest impact on determining a span's section.
So for the first task of predicting the section of a given span, our approach is as follows. We take a line from the Voynich manuscript and provide it to our model, VoBERTa, and output a prediction of what section that span belongs to. So now we'll talk a little bit more about our model, VoBERTa. Our model, VoBERTa, is heavily based on the XLM-RoBERTa multilingual language model. It's a model that's been trained on 100 languages and was released by Facebook Research. We take the XLM-RoBERTa model and do additional pre-training on it using unsupervised Voynich manuscript data. And then once we have constructed the VoBERTa model, we do additional fine-tuning using supervised Voynich manuscript data.
Next, we use Siamese network to predict whether 2 given spans belong to same section or not. A Siamese network is a neural network architecture that contains 2 identical subnetworks that have the same configuration, which is used for finding similarities between texts. So the embeddings of 2 spans from the VoBERTa model is given as the input to the Siamese network, which then calculates the cosine similarity between the 2 embeddings. This similarity score is used to predict whether the 2 given spans of text belong to the same section of the Voynich manuscript.
So for the third task of identifying the words that have the most impact on determining a given span section, we use the following architecture, where we take a line from the Voynich manuscript, provide it into our VoBERTa model, and then we output classification logits. And then using those classification logits, we generate Shapley values, which help us determine which words are able to most dominantly determine a given span section.
So we use Shapley values to determine the words that contribute most to each section. 2 criteria were used when analyzing the Shapley values, which are the sum of the absolute values and the maximum Shapley value for each word. By being able to categorize the words, we make strides towards determining the meanings of the words in the manuscript.
And now for the results. For the classification task, in which we were given a span of text and determining which section it belonged to, we achieved a 10-fold cross-validation accuracy of 91.52%. For the similarity task, in which we had 2 different pieces of text and determining whether they belong to the same section or different sections, we achieved an ROC-AOC score of 0.6356. The following table shows the words that helped most in determining which section each sentence belonged to. Overall, we were able to predict sections and similarity with relatively high accuracy. XLM-RoBERTa is trained on 100 languages and is able to extract language agnostic features, which is why it caught our interest. We found that pre-training the model on the text also helped improve the feature extraction. With our model, we can now identify words that determine sections with high probability. We feel that this is a significant step towards defining the words and the meaning of the Voynich manuscript text.
Thank you to our mentors, Jacob Lee and Sheila Mbadi, and thank you for listening.